Hello, APCSP. It's nice to be able to send you some personal messages every once in a while. I hope you enjoyed the last YouTube video that I sent you. That guy seems to really have like a green screen and everything. Sorry, I'm not that fancy. But today, first of all, I want to say I miss all of you. I really do. I don't know if I say this all the time, but planning lessons and grading papers is definitely not the part of teaching that keeps us, you know, inspired and motivated to be there. And we pretty much have been reduced to kind of just that. And so it's a little bit, it's a little bit tough to keep motivated when we don't have all of you in front of us to, you guys are what make the job interesting. You are the reason we are there. I don't get to see you doing your code and having those moments where you're like, oh, I get it, or yeah, it works. So I do miss you guys, and I hope that you are all well and that you are doing your work and you're not letting it pile up on you, because we will eventually get back to, I think, I'm still hopeful. I'm still hopeful. We will get back to school, and we don't want you to be overwhelmed at that point with things you got to catch up on. So, words of the wise, just, do it every day, what you're supposed to be doing, and also take some time to do things that you enjoy, maybe things you don't have time for usually. Personally, I'm trying to do that. I'm trying to get up and move a little bit every once in a while. My strategy is not to be super disciplined about exercise, but I'll scroll through my social media posts, and every time I see some ad for a workout video, I'll just do the exercises I see them do in that ad, and hopefully it's better than nothing. But anyway, I'm also making fresh bread in the bread maker, making bacon to make the house smell good, um, walking the dog, little things. Hopefully you guys are able to do some things that make you happy too, besides just schoolwork, because I know that that's not always going to be your favorite part of the day. But anyway, back to Create Task. Create Task is, we're going to start after spring break. And today I want to focus on showing you another sample and point out some things that, again, you could learn from before you get started. So I actually created my own sample project besides the grader that I showed you last time, where you could plug in grades and calculate your score. I actually have worked on a project of my own called a right triangle solver. And I would not ask you to do anything, like a create task that I wouldn't be willing to do myself. So I did the program, and I did it to the specifications of the College Board document. I documented my code. I made PDFs of my written responses and everything. So I'm going to show you that today. Here's the video I made of my program running. And I'm not really giving you the link to the program because you yourself, when you submit your program to the College Board, do not have to give them a link to the running program. You just have to show them a video of the program running. So here's mine. Uh-oh. I gotta get this thing to record the whole screen, not just the tab I'm on. 1 second. Okay, here I am on the right tab. This is my program. This is the video that I would submit. You'll notice it's 52 seconds long. It does not have to be an entire minute. It has to be less than a minute. So it's better to go shorter than longer, but take up a good portion of the minute. Don't try to just submit a 30-second video. The video is one of the last things you will create. Well, actually, it's kind of in the middle. After you create the project, you'll have to make the video so that you can talk about the video in your responses. All right, so here's it running. There's a start screen. There's a button. If you try to click solve it right at the beginning, nothing really happens. Then you can click on parts of the right triangle, put in a few parts, and then click solve it, and it supplies the rest of the values. You can put in angles. You can put in sides. You can put in a combination of angles and sides. It looks like in some cases, all right, and then it will solve the rest when you click solve it. You can reset, clears out everything. Here I'm going to enter a side 1 and a side 2 and a side 3. And if you know anything about triangles, that should not work. 1, 2, and 3 are not a valid combination, so it gives an error. Now, I kind of wish I had narrated this video, but I didn't, so I just narrated it for you now. That's a video. Doesn't have to have sound. It can just be clicks and showing on the screen how your program works. I'm going to take you back now to look at the written responses that I did to go with this video. Okay, here is my written response document. Question 2A. Remember that the prompt basically says you need to say what the purpose of the app is, what language that you created it in, and then describe what is going on in your video. That's what the prompt says for 2A. So I wrote, the program I created in JavaScript is a right triangle solver app. The user can input different parts of a right triangle, and the app will solve for the other missing sides and angles using trigonometry. The video shows the user first entering 2 sides, clicks solve, and the app calculates and displays the hypotenuse and both acute angles. Then the user clicks the reset button, and next enters 1 side and 1 acute angle, clicks solve, and the app responds accordingly by displaying the hypotenuse, the other side, and the other acute angle. Finally, the user attempts to enter just 1 acute angle and clicks solve. The app responds with a message, error, at least 1 side required. The user enters a side, and the app solves the rest of the triangle and displays the values. So basically, you get the idea that the first prompt 2A, you have to say what language you created it in, what is the purpose of the app, and then you describe what is shown in the video. You literally narrate in words what the person looking at the video should expect to see happening in the video. That's how you answer question 2A. Moving on to question 2B of the written responses. The prompt says, describe the incremental and iterative development process of your program, focusing on 2 distinct points in that process. Describe the difficulties and/or opportunities you encountered and how they were resolved or incorporated. In your description, clearly indicate whether the development described was collaborative or independent. At least one of these points must refer to independent program development. All right, back to my written responses. Here we go. My answer to that question is, I developed my app incrementally in separate stages. Each stage of the process included iteration of the steps of design, coding, testing, and debugging. The first stage was screen layouts and button design. In this stage, I tested the program flow without any computations. As I did so, I realized that one of the screens I had created was unnecessary. So I kept the introduction screen and the solve it screen. But there was no need to ask on another screen which part was missing on it. So I redesigned my button click event handler to skip that screen, then deleted that screen object. The second stage of development was prompting the user and capturing and storing the input values for computations. I wrote this code to build a string that represents which inputs were given. The third stage was to write code that would calculate the missing values and display them. At this stage, I encountered a challenge that some values didn't seem to be accurate coming out of the built-in trig functions. I had to read the documentation more carefully to realize that the angles must be converted from radian to degrees and vice versa. So I rewrote those segments of code to include this. Notice that I talked about how I had different parts of my development process. I had at least 2 stages of the development. First, I did the design and kind of layout of the program, and I made sure that the buttons, I could click between things and they were registering properly. That was my first phase of development. This addresses the incremental design process, okay? Different steps or stages of how you design the program. You don't just start from line one and just kind of go from top to bottom and write the whole program all in one step or one phase. It's just kind of probably better to like start simple. That's why in the suggested timeline calendar, I've broken it down into kind of like a beta version. I don't know if any of you are into like software releases, but a beta version is kind of like a stripped down, not quite full version for testing where people can try it out. And then, you know, if it goes well, then they release the full thing later. And they kind of work out the bugs that way. So it's probably a good idea to create a simple version of your app that just does kind of the basic structure. And then if there's anything complex about it, you add that in a second stage of development. And you describe that in part 2B because they want to see that you have a incremental development process. Now, in terms of iteration is doing something again, like, you know, repeating the same thing again and again. So I have those two incremental phases of development. I repeat the steps of design, coding, testing, and debugging. Okay, that addresses the whole concept of iteration. I had to kind of redesign, change the code, test that it's still working, work out any bugs, and then, you know, do that again. So notice that I also described two different challenges that I faced or opportunities to make something better. When I first created this app, it actually had like 3 different screens to go from there was an intro screen that did nothing except say what the app was about. And then I would click, you know, start, and it would go to a second screen. And on that screen, I was asking the user to tell me which parts it was gonna, like which parts of the triangles did they want to put in so that they could figure out which other parts are missing. But I decided that actually the third screen where it just shows the triangle and the missing parts, like I could just design the program so that they don't have to tell me. I just kind of can tell by what they've entered what the parts are and then work with that. So I described that challenge and my kind of change of mind in this answer. Okay. Then, of course, towards the end, when I was trying to actually calculate the values, I was using built-in JavaScript trig function math, you know, API commands, and I didn't realize that some of them had been giving me answers in radians versus degrees. So I had to like redesign and kind of, you know, do that little conversion myself in the program. So that was a second challenge or opportunity I encountered. Then how did I solve it? I rewrote those segments of code to do that. And I describe that in 2B. Okay. Now, part 2C asks us to talk about, see, are we still recording? Yeah, okay. 2C asks us to talk about the algorithm. Capture and paste a program code segment that implements an algorithm that is fundamental for your program to achieve its intended purpose. This code segment must be an algorithm that you developed individually on your own, and it must include 2 or more algorithms and must integrate mathematical or logical concepts. Describe how each algorithm within your selected algorithm functions independently, as well as in combination with others to form a new algorithm that helps to achieve the intended purpose of the program. There's the prompt again. Let me go back to my written responses. The main algorithm that I developed was called solve triangle. You can see it up here at the top of the code that I copied and pasted into this written response document with an oval around the algorithm. In fact, I probably could have just made the oval go around these lines of code up here, 63 to 66, because that's the main algorithm I'm talking about. But I kind of included the sub-algorithms here in the oval. I'm not sure which way is better, but I did describe it all in my answer. So the main algorithm I developed, called solve triangle, calls two other algorithms to accomplish solving all the missing parts. The two other algorithms that it calls are called determine case and handle case. So the determine case function checks for valid values of each of the 6 global variables which may have been entered when the user provided input. For each variable that has a valid angle or side length, a corresponding part name is added to the given string. For example, if the user entered a value for the hypotenuse C and an angle A, the constructed string would be given CA. Then this string is passed to the handle case function, which has all the logic built in for every possible case. Using a long string of if-else statements, every case has been accounted for, and the appropriate actions have been taken to compute the rest of the missing values in the triangle and update the screen accordingly. The computations are done with built-in JavaScript trig functions for some cases, and in other cases, Pythagorean theorem or subtraction from 90 for complementary angles. Sometimes there is a combination of algorithms used. That's my answer for part 2C. I have my main algorithm, which calls the other two algorithms. First, it has to determine which case am I dealing with, what parts have the user tried to enter, and then it has to handle each of the different cases differently. So that's a second sub-algorithm, handle the correct case. I built up a string that would kind of save what the cases were and then handle that case separately for each combination. All right, the last written response is talking about abstraction. You remember hearing about this. Abstraction is, if you, as a student, develop an abstraction, it's probably a function. So I focused on a different function for this answer. I could have focused on the same function up here, solve triangle, and talked about how that's an abstraction. It was really kind of an arbitrary choice for me to just pick a different function because I had so many functions written for this program, and I felt like talking about something different this time. So one of the abstractions I created in my code is a function called 3sidesValid. It helps manage the complexity of my solve triangle function by hiding the details of that task of validating the 3 proposed side lengths to determine if they are actually able to form a triangle. This is necessary for the case that the user enters all 3 sides and wishes to solve for the acute angles. Before attempting to compute the angles, I use this function to check whether it is a valid right triangle. The details of this task are abstracted out of the main algorithm, and it includes calling 2 other functions, canFormTriangle, which checks by the triangle inequality theorem, and fitsPythag, which checks that the Pythagorean theorem is satisfied. If the function returns false, the solve triangle function will respond by displaying an error message to the user and not computing the acute angles. The user may then enter new values and try again. So it describes how my abstraction manages the complexity by packaging up all this detailed work into one place. And it describes what that stuff is, and then it describes how it works and that I developed it. And I kind of, by showing my reasoning, prove that I developed this function. I didn't just steal it from somewhere. So a lot of the time in your written responses, you have to think that way. Like, they might be asking you to describe something just so that it looks like you understand what it's doing and why. And you putting it in your own words helps them to know that you didn't necessarily plagiarize this or get it from someone else helping you. So that's part of the reasoning behind having these written responses. All right, that's my sample task. Now I'm just going to show you one more. document that I included was all the code in a PDF for this file. It's this middle link here, create task code. And in that code document, you will see the global variables at the top, and I've got comments to describe things. And then there are event handlers, because I did have interaction on the screen with people being able to click on objects and then, enter values and be able to pull those values in and then use them for things. So then my event handlers came next. And then finally, down here, starting at line 63, I've got my other functions that help to break down the problem into smaller problems. The one main event that kicks off the solving of the triangle is right here between lines 59 and 61. If a person clicks on the solve button, then I just call this function called solve triangle. So that's really doing the work of getting it started. But hopefully they won't click on solve triangle until they've already clicked on the other things and put values in. But I do have verification built in that if they didn't click on anything else and everything's just zeros, it's going to return an error. It's not going to work. So that's all behind the scenes. But I did put the oval around my code, and I will give you instructions on how easiest to do this. There's a nice little tool that you can just copy paste your code into it, and it will easily allow you to add an oval around a certain portion of your code for the algorithm that you want to highlight. And notice that I did kind of include like this function and the header of this function, because those are the two sub algorithms that are called from my main algorithm. So here's the one sub algorithm, here's the other sub algorithm. The reader could then like look down and see the rest of that algorithm if they really wanted to, but it's pretty long, so I didn't want to put an oval around the entire thing. So many different cases, and it's probably not very efficient. Maybe there's a better way I could have designed this, but I just kind of got into it and just kept going until I got it all worked out. One day, maybe I'll go back and make it somehow more elegant and efficient with fewer cases required to do the same job. But anyway, I've got a bunch of other functions down here. I put comments near things to describe what they're doing. Here's my rectangle around the abstraction. The rectangle seems to have moved a little bit, but it's pretty good. It's around my fits Pythag. That's what I was describing in the 2D answer. I could have put it around kind of any other algorithm. I've got lots of functions in here. But that's how your code would be captured and put into a separate PDF document to upload to the College Board digital portfolio. There will be 3 things you have to upload. There is the video, the written responses, and the code document. And there will be 3 columns in the digital portfolio for uploading them for this task. All right, that's what I've got for you today. I'm going to have you fill out a couple questions about what you've learned so far and how you're doing. And I will talk to you again next week or next class for those who are watching this on Monday. Yeah, I guess it would be next class. I'm making this on Friday. But anyway, hope you had a nice weekend by the time you watch this, and I'll talk to you soon.